If we have two masses, one at random point, mass m1, and another random point, m2, and we choose a coordinate system with an origin and another random point, so for example we can choose an origin at this point, and we connect the origin to the location of the masses with a vector. So for example for m1 we'll call the vector r1, for mass 2 we'll call this the vector r2. Then we know that the vector connecting them will be this one right here. That can be found, I'll call this cursive R, actually I'm writing why, because this is not the wrong one. Cursive R is equals to R1 vector minus R2 vector. Okay, and now if I want to find the center mass, the CM, I will have then to use another vector R. Starting from the same origin, then we can say m1 times r1, r1 plus m2 times r2 over m1 plus m2. So for example, if I say that m1 is a little bit bigger, then this vector will end up being something like this. It's capital R vector. And here will be the R point. At this point, actually, and then if we say that m1 plus m2 is equals to capital M, we can see that now we have a correlation between these two. And we also know that there's this value right here. So if I start rewriting this R vector, and I want to find it what it's equals to in terms of R1 and R2, then I'll know that capital R is equals to M1 times R1 vector plus M2 times R2 vector over capital M. Now, I know that R1, for example, is equals to the cursive R minus R2. So I can substitute it in here. So I get that capital R is equals to M1, and then we have cursive R minus R2 plus M2 R2 over capital M. So let's solve this. Well, we get that we have R vector. Actually, I'm gonna do something. Okay, R capital M is equals to M1 cursive R minus M1 R2 vector plus M2 R2 vector. So I can move the M1 small and the cursive R on the other side, so I get that capital R M minus M1 cursive R is equals to, well, then I collect the R2 vector is equals to M2 minus M1. Okay. And then I divide it on both sides, so I get that capital R. Sorry, let me check one thing. Okay, capital R times capital M is minus M1 capital R over M2 minus M1. I think I'm gonna mistake somewhere. Let me just find it where it is. Because this should be a positive. And oh, yes, here R1 plus R2. Mistake there. So here it becomes plus, 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 like we said, and plus. And as you can see, is equals to R2 vector. Therefore, we get that R2 vector is equals to, well, M1 plus M2 is equals to capital M, so simply R2 capital R vector minus m1 over capital M, and then the distance vector r. And these are R2. Now, if we want to do the same thing for R2, and we want to find R1, then R2 is equals to R1 vector minus R, distance vector. Just make sure I want to make another mistake again. It looks correct. Okay. So if I go back and I just substitute it inside of here, because that's when we substitute our initial one, and I substitute it for R2, so we get capital R is equals to M1 vector 1 plus M2 times R1 vector minus capital R vector over capital M. So capital R is equals to M1 R vector 1 plus M2 R vector 1 minus M2 distance vector over capital M. Actually, I'm just going to write it on the other side. Multiply both sides by M. Okay, so let me collect that. Capital M R is equals to R1 vector is equals to M1 plus M2 minus M2 distance vector. So I'll move that to the other side, and then divide everything by this value over here. So we get that R1 is equals to capital R plus M2 over capital M distance vector R. And these are our two values that we have right here. Now, one thing that we can look at, let me just show you see it. One thing to look at is the Lagrangian of this. So, Lagrangian of the initial system will be equals to 1 half m1 r1 dot squared plus 1 half m2 r2 dot squared minus u of r. And if you substitute what we have in here, let me just copy it and paste it down so we can see it. Then we get it's equals to 1 half m1, and r1 is equals to that value, so capital R vector plus m2 over m distance vector having squared plus 1 half m2, and then r2 instead is equals to capital R vector minus m1 over capital M distance vector squared minus u of r. Okay, so let's solve this. We get 1 half m1. Oh, sorry, actually, it's gonna be the derivative of this because it's r1 dot. So all this will be dot 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 dot. Because of course r1 dot is equals to capital R dot minus m2 over capital M distance vectors dot. And same thing for R2, of course, here plus. Okay, so we get R capital R dot squared plus, let me just keep it in parentheses, actually, it just makes it easier to write. M2 squared over capital M squared R dot, actually, R vector dot squared plus the dollar product, of course, 2 capital R M2 over capital M times distance vector plus 1 half M2, and then here we get pretty much the same thing. So we get R vector dot squared plus m1 squared over capital M squared over distance vector squared minus 2 capital R m1 over capital M distance vector. Now of course these are vector and dots. Minus u of R. Okay, so if we solve this, multiply everything, we get 1/2 m1 R dot squared plus 1/2 m2 squared over capital M, m1 in front of course, capital M squared distance vector dot squared, plus, and then we get m1 times R, here with the dot, m2 over capital M and distance vector, yes, plus 1/2 m2 capital R dot squared plus 1/2 m2 m1 squared over m squared capital R dot squared minus m2 capital R dot m1 capital M R vector distance dot minus u of R. So if you notice, we can cancel out these two values, and then we can add some things together. For example, well, not exactly add, but we can collect. We're gonna get these two values are very similar, so we're gonna get 1/2 R vector dot squared times m1 plus m2 plus, and then we have these other two values left. We can collect again 1/2, and then we get m1 times m2 squared over capital M squared R vector dot squared. Okay, minus u of, actually I'm sorry, I'm getting a little confused. Let me go back. 1/2, and then we take the first one and second one. What do they have in common? Well, they have in m1, m2, m1, m2, and the first one will have in m2, second one will have in plus m1. Okay, that makes sense. M squared distance vector squared, of course. So now I can cancel these two things out, and I get that my Lagrangian is simplified to 1/2 the distance from the center of this mass, the center of equilibrium, times the capital M, of course, plus 1/2 m1 times m2 over capital M, weird, okay, times distance vector dot square. And I can say that if I write this new constant, or constant, actually this new variable called reduced mass, that is equals to, I wrote 2 times the same thing here. Okay, m1 times m2 over capital M. I can simplify this and only write it as 1/2 R dot vector dot squared capital M plus 1/2 this reduced mass times the distance vector dot squared. And here is how we can solve our equation. And these are the first two sections of this new chapter. They all are a big, long mathematical explanation on how to get to this point.